guys, in today's video we're going to be looking at modulus equations and inequalities. Right. This is an extremely common question in the IB exam. It can come up on both paper 1 and paper 2. But if you're unable to sketch these modulus equations, like or the modulus of f of x and stuff like that, then you can look at my previous video where we do go over the modulus of f of x and the modulus and f of the modulus of x from the graph of f of x. It's a very common question. You will be asked to either draw or solve these modulus equations, whereby if you're graphing them, then it can be up to like 3 marks. But I think typically the modulus equation and the inequality section, they're like 2 or 3 marks at the end of a question, the end of a big question. I think they're very easy marks to get, and it's a good skill just to have under your belt. All right. So the first thing that we need to know is that a modulus equation is an equation that involves the absolute value function. If you don't know what the absolute value function is, I went over it in my last video, but it's basically y is equal to the modulus of x, whereby the modulus of a number, so let's just say we have any number here, where n is just an element of the real number system. Well, what is the modulus of n? Well, it's literally just how far n is from 0. So it's the distance that n is from 0, right? And we would say that as n. And therefore, it cannot be less than 0. So to solve these modulus equations, we need to use the definitions of the absolute value and properties. Right, certain distinct properties. So the first property that you guys need to know is that the modulus of x is greater than 0 for all of x, whereby the absolute value of the modulus of x is literally just the distance that x is from 0 on the number line, and therefore it cannot be a negative because the distance can't be negative, right? Another important one, this is one of the most important ones, is that the modulus of x squared is equal to x squared for all of x. We're going to use this one in particular to solve a bunch of examples. Now we can also have the modulus of x over y equal to x, modulus of x, modulus of y for all x and y. This is going to help you manipulate certain equations to make it into, or to put it into a format that's more familiar and you're just more comfortable with solving. Negative x is equal to, the modulus of negative x is equal to x, because if you look at it on a number line, again, we have x here, minus x here, same distance from 0, they're just in different directions, not a negative distance, can't have a negative distance. Modulus of x times by y is equal to y. These can be any number, but I'm just using x and y just to make it a universal, so we're just putting it in a general form. Minus y due to y minus x for all x and y. Right, so if we actually, so we notice that in particular that if x is equal to a, and a is greater than 0, of course, because it's a distance again, then x squared is equal to a squared, and hence x squared is equal to a squared, as the modulus of x squared is equal to x squared, right? And therefore x is equal to plus or minus the square root of a squared. If you're wondering why I've done that, I've just square rooted both sides. So Therefore, x is equal to plus or minus a, because these two cancel out and you just get plus or minus a. Whereby so therefore it can be stated that if ax, the modulus for x, is equal to a, where a is greater than 0, then x is equal to plus or minus a, right? So if we solve a modulus equation, we can follow the plus or minus approach on one side that represents taking the negative of the modulus argument. So what we can do, so say that we have something like this, 2x plus 3, modulus of 2x plus 3 is equal to 7, and 2x plus, therefore it can be stated that 2x plus 3 is equal to plus or minus 7, where this is our x, this is our a, right? And then we have a plus or minus, but this will allow us to set up two equations and solve for the values of x, right? This is called our plus or minus approach, right? And I'm going to go through a bunch of different examples for us to go through using the plus or minus approach. However, we can actually have another approach that we can use, that if we solve a modulus inequality with the plus or minus approach, that it's problematic as it involves multiplying the inequality with -1. So we either have to square out the modulus or split the modulus on its own side of the inequality. Drawing sketches here are useful but not always necessary for linear ones. So for example, what that is basically saying that if we have 3x plus 1 is greater than or equal to 2x minus 3, so the modulus of both, then we get 3x plus 1 squared is greater than or equal to 2x plus minus 3 squared, right? However, this can only work when they're linear, because if you do have like a quadratic function, I'll show you here, x squared plus 3x is greater than 2x plus 2. What would happen if we use the square approach? Well, you would end up getting a quartic, because x squared times x squared is equal to x to the 4, which isn't helpful. So instead, we solve the two inequalities by splitting the modulus on its own side. This is very important. So this is using basically the plus and minus approach, but with an inequality. If you guys don't understand this yet, you probably will once you go through examples. I'll start from the bottom and then slowly build our way up. So x squared plus 3 is greater than 2x plus 2, because it's our positive. And then we have negative x squared minus 3x is less than 2x 2. Right? So it's our negative side. That's how we solve them. So, sketching here is useful because solving quadratic inequalities on their own can lead to misleading results. Instead, find the x values only when they are equal and then compare these with your sketch. Alright. Or you can factorize if you have the formula. So, let's start off with a couple of examples. So, let's say we have the modulus of, let's say, 2x plus 3. So, modulus of 2x plus 3 is equal to 7. Well, then, therefore, 2x plus 3 is equal to plus or minus 7. This can be our x, this can be our a. But we know that the modulus of x is equal to plus or minus equal to a. Therefore, x is equal to plus or minus a, right? So this leads us down two routes. Well, we have one where 2x plus 3 is equal to minus 7. And we have one where 2x plus 3 is equal to 7, right? It's our negative side, it's our positive side, obviously, right? So how would we solve this? Well, I'm assuming you guys can solve a linear equation for x. So we have x is equal to -5, that side, and we have 2x is equal to -4. No, just 4, sorry. Then we have x equal to 2, alright? Now, let's try another one. 3 minus 2x modulus is equal to -1. I want you guys to try to solve this. Alright, so this is actually kind of a trick. This has no solution, as the left hand side is never negative, right? Well, Why? Well, because we know that the modulus or the absolute value of a function can never be negative as it's its distance from 0. Therefore, if it's equal to -1, then that will just be incorrect and it cannot be solved, and therefore having no solution. Now let's try it when we have a fraction. So let's say we have 3x plus 2 over 1 minus x is equal to 4. Well, how would we solve this? Well, we can still use our plus and minus approach. No matter if it's a fraction or not, we can still use that approach. 1 minus x to plus or minus 4, right? Where this is our x and this is our a, right? So we have two roots that we have now. We have 3x plus 2 over 1 minus x is equal to -4, and we have 3x plus 2 over 1 minus x is equal to -4, right? So what does this mean? Well, now we can solve these two equations. So on this left hand, so this will be our negative side. So our positive side, obviously. Yeah, I accidentally put a negative there. It will be positive. Alright. So for our negative side, we would simply just multiply the 1 minus x over. So 3x plus 2 is equal to -4. So 1 minus x, and we just expand the bracket. So we get -4 plus 4x. And then we can subtract 3x from both sides, so we get 2 is equal to -4 plus x, therefore leaving us with x is equal to 6, where we add 4 to both sides, so we get 6 is equal to x. Alright, that's only our first solution. That's our one solution. Now we have the positive side to deal with. Thereby, we do the same thing, we just multiply both sides by 1 minus x to get 4 times by 1 minus x, so we get 3x plus 2 is equal to 4 minus 4x. Now we just add 4x to both sides, so we get 7x plus 2 is equal to 4. Then we have 7x is equal to 2, then therefore x is equal to 2 over 7. These would be our two solutions. Alright, let's try another one. Let's say we have x plus 1, the modulus of x plus 1 is equal to 2x minus 3. Alright. So it can be stated now that x plus 1 is equal to plus or minus 2x minus 3. The same approach, guys. So yeah, you can see that it's very copy and paste, and it's quite easy when we have linear equations. We're going to go through other ones where we're going to have inequalities and quadratic inequalities, which are much more common and much more likely to come up in your exams. So yeah. So now we have our, but this is important just to figure out the basics. So we have x plus 1 is equal to minus 2x minus 3. Make sure the entire side is encapsulated in brackets so that we can make sure that the entire thing is being multiplied by the minus, right? And that's extremely important, and that's kind of the only way you would really mess up on these questions. 3. And this is the positive side, this is the negative, so we have negative, positive, right? So if x plus 1 is equal to negative 2x plus 3, we subtract, we add 2x to both sides, so we get 3x. 3x plus 1 to 3. And then what do we do? Well, we just subtract 1 from both sides, so we get 3x is equal to 2. Therefore, x is equal to 2 over 3. And for this side now, x plus 1 is equal to 2x minus 3. This is the positive side, nothing's happening to the right. So we have x plus 1 is equal to 2x plus 3. And 2x minus 3, sorry. And it's kind of the same thing. So we subtract x from both sides, so we got 1 is equal to x minus 3. Then we add 3, so we get 4 is equal to x. Right, and these would be our two solutions. Right. Now let's try to do some inequalities, alright? Alright, so let's do some modulus inequalities. So let's say we have modulus of 2x minus 1 is less than 3. So how do we solve this? Well, it's kind of the same thing, but we will have 2x minus 1 is less than plus or minus 3, right? However, this is the part that's different. 2x minus 3 will be less than 3, right? Because we know that this is our opening statement. This will be true. However, it would be greater than negative 3. Well, why? Well, so say we have the statement here. 4 is less than 5. This is correct, right? We know that this is right. However, when we take the negative off the right-hand side, we'll achieve this, which we know is incorrect. Therefore, when we switch the sign of one side of the inequality sign also switches, so we would actually get 4 is greater than negative 5, right? That's the same thing, that's the same principle that's happening here, right? Alright, so now we just solve this inequality. We add 1 to both sides, so we get negative 2 less than 2x, which is less than 4. Then we divide both sides by 2, minus 1 is less than x, which is less than 2. Alright, now let's try another one. We have 4 minus x is greater than or equal to 5. Well, we would have a positive and a negative side, so negative side here, so we'd have 4 minus x is less than or equal to negative 5. Switching the sign, because we know that this becomes negative, so the sign also switches. Right? Then on the positive side, we'd have 4 minus x is greater than or equal to 5. And then we just solve for x. So on this side, we would get x is... so I'll do this one step by step so you guys understand what's happening, I mean. So we get minus x is less than or equal to, so we subtract 4 from both sides, so this actually becomes negative 9. Now, we have negative x. We have this x is being multiplied by negative 1. Yeah? So we can divide both sides by negative 1. So we'd have x is now greater than or equal to, because we know we're changing the sign, right? We're changing the sign. So it's greater than or equal to 9, right? Then now let's deal with this side here. Here we have, so we would subtract 4 from both sides. We have negative x is greater than or equal to 1. Well, we have a negative 1 that we're multiplying by now. So we divide both sides by negative 1, and we're switching the sign because it's a minus 1. And these would be our two solutions. The hardest part here is literally just switching the signs, I'm not gonna lie. It's quite easy. And it's, for some modulus inequalities, it is easy just to separate the inequality into two, like here. I separated them into two because I find it easier to inspect both sides and just solve them and then put them all together, right? Alright, so now let's move on to some slightly harder ones. Let's say that we have 3x plus 1 is greater than or equal to 2x minus 3. Alright, so what would we do here? Well, you could do the plus or minus approach. However, I would say it's more, you should try to do the squaring approach now. So what would we do? Well, we'd square both inequality sides to get 3x plus 1 all squared is greater than or equal to 2x minus 3. Here you shouldn't be doing the plus or minus approach. You should be squaring both sides, because we know that the modulus of a squared, so squaring the modulus of a squared, the modulus of a squared is equal to a squared, right? So therefore, we can write it, we can do the same here. We're just applying this rule. So what would we get? Well, we would get 3x plus 1 squared. Now we got rid of the modulus signs, haven't we? Because you squared a modulus of a number to get just the number squared. So that's what I meant by that rule is going to be extremely important. So now what do? Well, we just expand the brackets and solve. So 9x squared plus 6x plus 1 is greater than or equal to 4x squared minus 12x plus 1, or plus 9, sorry. So what do we do now? Well, we try to make one side 0. So how do we do that? Well, we transfer everything from one side to the other. I think it's easier transferring from the right hand side to the left, because we don't want to have a negative x squared. We want the coefficient of x squared to remain positive. So we'll just leave us with, we get 5x squared plus 18x minus 8 is greater than or equal to 0. Now, what do? Well, we solve the equation to get our two brackets. So we factorize it. Sorry, not solve, we factorize, and then we can get our solution. Our solution set, that's 4 greater than or equal to 0. I'm assuming you guys know how to factorize a quadratic. This is quite GCSE. I think quadratic inequality equations, that's a GCSE topic, so it's quite easy. So you might not be awarded as highly for doing this in an exam because it is lower level maths. So yeah. So now, if you're wondering how we can get our solution, well, this basically means it's greater than 0 is literally just where y is greater than 0, because we know that this is a function of f, but it's f of x, so f of x is equal to that. And we know that f of x is equal to y, therefore this is where y is greater than or equal to 0. If we sketch this, right, so we have our solutions here. We have negative 2 over 5. If you're wondering how I got that, I just did 5x minus 2 is equal to 0. And then we just did x is therefore equal to 2 over 5, right? And then for this one, x plus 4 equal to 0, therefore minus 4. Therefore x is equal to minus 4, right? So that's what we would draw on our graph. So we'd have 2 over 5 here, minus 4 here, and you just simply draw a quadratic. It doesn't have to be accurate, you just have to show that it's going through the points, and you need to be able to see where. So we're looking at where y is greater than or equal to 0, right? So where is y greater than or equal to 0? Well, it's up here, and here. But how do we express this? Well, it's where x is less than or equal to negative 4. So x has to be less than or equal to negative 4. Because it's greater than, y is greater than 0 for this section here, right? And then what about 2 over 5? Well, x has to be greater than 2 over 5. So 2 over 5 is less than or equal to x, right? Because why? Well, look here. We're focusing on this segment of the graph here. And this is where y is greater than 0, right? So where is y greater than 0? It's where it's over here, where x is greater than 2 over 5. You can even draw a sign diagram for this function if you really wanted to. We'd have x, we'd have the key values of negative 4 and 2 over 5, showing it's negative here, positive here, positive here. So every x value that is less than minus 4, and every x value that is greater than 2 over 4, 2 over 5, I mean, will give you that solution. Let's try another one. So let's say we have x over x plus 1 greater than or equal to a half. We can still do the squaring of both sides approach again. So we just get we square this, x over x plus 1 square greater than 1 over 2. This is the exact same as doing x 1 squared. So what do we get? We just get x squared over x plus 1 squared greater than or equal to 1 over 4. Now you just solve for x, we get x squared is greater than or equal to a quarter multiplied by x plus 1 squared. And to eliminate this a quarter, we just divide by a quarter from both sides because we're multiplying it by that. So we divide everything by a quarter. Divided by a quarter, same as multiplying by 4, so we get 4x squared greater than or equal to x plus 1 squared. Right, so what do we do now? Well, we've got a quadratic, so we expand the brackets on the right hand side to achieve that 4x squared is greater than or equal to x squared plus 2x plus 1. Then we just transfer everything onto this side because we have more x squares on the left. So we have 3x squared minus 2x minus 1 greater than or equal to 0. Now we just factorize, so we get 3x squared. And we get 3x in a bracket, so bracket 3x plus 1. And x minus 1 is greater than or equal to 0. To get our solution set, we have negative 1 over 3 and 1. If we set them both to 0, that's what we achieve. And what we're looking for, where y is greater than or equal to 0. So we draw it onto a graph. My negative 1 over 3 and 1. Now we draw it. Where is it greater than or equal to 0? It's up here. up here, therefore it can be stated that x has to be less than or equal to negative a third, and x is greater than 1, right? If you're unsure where I got that from, well, this just means this function has to be greater than 0, so y is greater than 0 here. Y has to be greater than 0. Where's y greater than 0? Well, it's up all the way up over here and here. Then what does that mean for the x values? Well, that means that it's greater than 0 for where x is greater than greater than 1, because it's greater than 0 over here. And where x is less than or equal to negative 3, and which is this section here. Alright. I think that'll be it for this video, guys. Thank you guys for watching, and I'll see you guys in the next one.